So now I'd like to introduce our speaker today, Derek Jacobs. Derek is the structural department manager at ADF Engineering and has over 16 years of experience in structural engineering and project management, working in a variety of fields such as food, feed, bioindustry, product manufacturing, and medium and heavy industries. His expertise covers structural condition assessments, OSHA compliance, and wind and seismic design. Derek is also skilled in personnel management, project definition, proposal development, and cost estimation, as well as collaborating with contractors and providing on-site construction support. So now I'll turn it over to Derek for today's presentation.
Okay, thank you, Tim. Right, so today we're going to talk a little bit about fall protection. We get a little questions every now and then. And the one thing I really kind of want to highlight in the presentation is that the rules and things regarding and that are factors that are at play for fall protection are constantly changing. And it's kind of important to stay up to date on some of those things. So the first pop-up windows here. First thing I want to kind of go over, and we had a presentation not too long ago for kind of our structural engineering basics. I would recommend any of you guys that haven't seen that or are interested to check that out. But I do kind of want to go over real quickly before we start kind of what a structural engineer does for those that are unfamiliar. So the structural engineer is the person who will evaluate any kind of building, any kind of steel, any kind of concrete that is going in or is being affected by any kind of change or design of a new building or anything in a building. We look at the materials and the sections and types of things that are impacted, and then we determine those capacities. We have a couple different types of steel sections here. You'll see us refer to these every now and then, and it's kind of helpful for you guys to maybe understand most of what, for example, most of what we look at and people refer to as like an I-beam is actually a kind of a W shape, sometimes an S shape. The way those are kind of distinguished or labeled are usually by two numbers. The first one would be the depth or the height of any given section, and then the second number is always going to be the weight per foot of that. So that's how make that a little clearer. And then we also look at tube steel shapes or HSS shapes, and those are a little bit more simpler. They're just the three numbers that are the height, width, and thickness dimensions, and then plates similarly with the thickness first, and the long side and the short side coming in after that. So we take those sections, we look up, evaluate based on what kind of material they are, what those capacities, how long they are, what strength we can get from those, and we compare those to load requirements. And in this case, we'd be comparing that to the loads required for fall protection, right? So how do we determine what those are? Well, first we need to understand what the rules are that govern the design and the care and use of a fall protection system. So we'll kind of go into that. There's a couple different places that come into couple different people that kind of give guidance on those kind of things. So we'll look at that. But then once we have those loads and what we're actually designing that for, we'll take that into account and compare that with the capacity of like any kind of structural system that we're designing that would be what we're going to call an anchor system for that fall protection. And sometimes when we're in an existing site or a brownfield site, we not only have to take into account that load, but the weight of any kind of other materials, such as a large piece of equipment, heavy weight of like in a flooring system or any kind of live load that might be on that same floor. Like for instance, the beam that we're attaching to is also part of a floor system or a roof system. So sometimes that results, when we're designing these in what we call a conditional use, where for example, a fall protection system can be used. It's always fine, except, if it's a roof system and there's, a couple feet of snow on the roof or something like that, or if a large piece of equipment is, in the same area or, in full